Hello and welcome. Thank you for joining me today. Today I will be discussing the ethical theory application for autonomous semi-trucks. This is for a class here at Kennesaw State University, MTRE 6750, Ethics and Robotics. Without further ado, let's get into it. So the summary of topics that will be covered today will be first the technical background, going through exactly what autonomous semi-trucks are, literature review, identifying publications that have been published to address autonomous semi-trucks or self-driving semi-trucks, ethical theory explanation, so going through the ethical theories that were studied and how it actually applies to the autonomous semi-truck industry and domain, and then overall application of which ethical theory will be advantageous to the development of autonomous semi-trucks. So what exactly is an autonomous semi-truck? So autonomous semi-truck, also known as self-driving, is essentially a tractor trailer 18-wheeler that has the ability to operate on its own, similar to how a human driver would operate the vehicle. So it's able to make decisions as far as overtaking, lane changing, and getting from one point to another, point A to point B, with the use of various technologies mainly around the sensor technology such as LiDAR, radar, time of flight cameras, sonar, GPS. So a vehicle that is able to operate on the roadways without a human driver. Kind of a further deep dive into exactly what it is and how it works. So in the engineering space, it's basically uh, a system is comprised of three components, one being the input, then the process, and the actuators. So for the autonomous semi-truck, the input sensors would be the devices that take in information from the cameras, GPS, and radars to help the truck or the platform understand where it is in the environment and exactly where it needs to get to in order to complete its task. The process or control module is essentially the brain of the platform or the vehicle. It allows the vehicle to process or to analyze the information, make a determination, and then from there moves to the actuator. And this is basically the systems that the vehicle uses to control where it is in the roadway. So this steering for control, braking, propulsion systems, etc. Most of this is usually done through Control Area Network or CAN. J1939 is the standard which it applies. Um, and this is usually just the standard approach for developing autonomous vehicle systems. Take a short dive into maybe more of the sensor technology. Many sensors uh, are used, so there's pros and cons to kind of each of the off-the-shelf components, from cameras being, high resolution, but they don't do too well in low light conditions or adverse weather, rain, snow, sleet, versus something like a LiDAR, which is unaffected by weather conditions, although it's very expensive and it has a huge cost impact. And then of course radar is inexpensive, but it's low resolution and no color, so it's um, the combination of these sensors is usually the advantageous approach in order to help the autonomous system navigate within its respective environment to the capability of maybe like a human would operate. Here's just a slide just to reconfirm that point. So sensor fusion, so taking the three sensors and leveraging their strengths in order to create the best capability, right? So no single sensor can perform the job of autonomous driving. It takes a combination of the three good diverse input technologies used to navigate all the potential obstacles, as you can see from object detection, night driving or darkness availability, weather robustness for parts of the country that have inclement weather more often than not, and even distance measuring. So, sensor fusion, leveraging a combination of the three different sensors or even more, is the approach that many autonomous OEMs, manufacturers, and innovators are taking in order to achieve autonomous driving. And this kind of just provides an overview of the different capabilities needed to help kind of achieve that perception system of autonomous driving. As we see the image here on the left, with the various fields of its overall detection, starting at the furthest of object detection, getting to the closest of collision mitigation braking, and then the image here on the right. So it further breaks it down as to the various fields of view that the sensors will be able to use, from the short range radar to the stereo camera is kind of further out, and then you also have the long range radar um, that can help. So it shows the leveraging of three different perception devices used to solve the problem of autonomous driving. So the current landscape is that there are many companies in the space of autonomous driving, specifically around semi trucks and 18 wheelers, looking to create kind of the first platform or model, achieve success from over the road long haul trucking to last mile delivery, in order to be a pioneer in the space. One organization here in the middle, we have Waymo. So Waymo has been a pioneer in the self-driving autonomous semi-truck space for quite a while, leading the charge, becoming a disruptor in that field with, like I said, leveraging sensor fusion. They're one of the first ones to start the development of three diverse perception devices in order to kind of solve the problem. They've been working on using machine learning as well to help the platform learn some of its shortcomings and faults and adjust accordingly. And then also with the safety systems such as the autonomous braking capabilities that has kind of been mentioned and discussed in the public view. So here we have an image of Waymo's truck and basically how the truck has the various locations for some of the sensor technology, from the mirror and stereo cameras, from the radar sensors, and also the sensors for the braking, autonomous braking systems as well. So it's placement on where these perception devices goes makes a lot of difference. We want to make sure that they're unobstructed, that they have the most field of view, and that they are angled in a way to help mitigate and reduce the amount of blind spots that also could be introduced. All this is important. We are trying to replicate as much as possible the abilities of the human driver, right? So a human driver, we have the same three components of our system. From our five senses would be our input, our brain is our processor to analyze the information, and then our extremities, hands, arms, legs, feet, would be our actuators to control the system as we receive the information. So we're trying to replicate that into a vehicle to help remove the driver 100%. A lot of our semi-autonomous or driver-assisted systems still have what's called human in the loop. So the human is the last line of defense, but moving into autonomy, we won't have that option, or we prefer to not have that option. So it's um, the task of trying to find a way to make sure the vehicle can mitigate such situations as quickly as possible, but we first have to make sure that they have the information. So that's why the sensor technology is critical. And just a caveat on the last slide, just more information about how Waymo is leveraging multiple perception devices, even multiple of the same, right, redundant inputs. We can see here that they leverage three cameras, three LiDARs, and two radars in various locations. This can help with redundant inputs in case there's some type of dependent failure or common cause failure between any of the systems. It would be able to be detected through, like I said, the processing, the brain unit of the vehicle, and the vehicle can usually degrade to some lower mode of operation or reduce functionality in order to bring itself to a safe state. So now that we covered kind of the background of the technology, exactly kind of what it is, maybe what some of the challenges are, and who is one of the rock stars in the space, we will discuss some of the ethical concerns with autonomous semi trucks. The first one being technological unemployment, the Frankenstein complex, potential cybersecurity attacks, and then the trolley problem. So for our first topic here, technological unemployment. This is basically defined as unemployment due to advanced technology kind of coming in. So with the increasing push and presence of artificial intelligence and advanced robotics, many jobs, positions, careers, even industries are becoming displaced. So many people are losing their jobs and finding themselves unemployed due to being replaced by technology. So if we look here on the left, then back in probably years ago, mostly the 70s was considered the golden age of trucking. It is classified as a blue collar field, so you don't need an advanced degree, bachelor's degree, anything like that. But it was a blue collar field. It is a blue collar field that has the ability to make I guess, a decent living for an individual. It has a lot of, or it had a lot of upward potential from truck drivers being able to first kind of learn on the job. A lot of trucking schools allow you to learn while you earn, as they call it. You also have the ability to own your own truck and trailer, right, which is called owner operator, and then hire yourself out to various companies, go to kind of load boards. You can also contract yourself through the federal government to help move some of their logistics or packaging and equipment to various locations and sites. So it was a path of wealth for many blue collar workers, and it had the ability to kind of chart your own destiny. As we can see now, like I said, we're moving into more autonomous trucking with AI being the go-to worker for over the road or long haul trucking. This would significantly impact the ability for human workers to kind of make their own money because there will be probably a reduction. Of course, AI can drive longer without breaks. They probably have less amount of money. They have to pay in maintenance and kind of less quote unquote hassle, if you will, dealing with a computer versus an employee. Maybe less regulations from the company. But we will start to see that this autonomous trucking initiative will threaten jobs, will start to displace and replace those truck drivers who are often stated to be the backbone of America, moving logistics from one part of the country to another. So it's definitely a concern that we should consider. Uh, the next concern, ethical concern, is what's deemed as the Frankenstein complex, right? So this just basically the fear that our creation, robots, if you will overtake society. We can see this kind of in pop culture, right? So on this slide here, we basically have two pop culture references. I mean, there's a lot. The first one being it's a pretty widely known show, Supernatural, about two brothers who hunt down supernatural events. And then this season and episode, their car, basically 1965 Impala, came alive and started basically haunting them, trying to run them over, essentially. So it's concerned that if cars do possess the ability to operate autonomously, what will be their control to make sure that they don't start to deem themselves as superior and try to unalive humans. And then on the right here, we have popular cartoon animation, Rick and Morty. Basically, Rick's spaceship came alive, kidnapped the children, and basically went on her own adventure, holding the children hostage, essentially blackmailing them to take the rap for her adventures and indiscretions because she wanted to experience things that she felt like she deserved. Um, so definitely a concern that we probably should focus on. More so public perception. So having ways to help the public understand that maybe these things are a little bit far-fetched, or that there are checks and balances in place to kind of help mitigate the potential for that situation. And then we have potential cybersecurity attacks. Turn the sound off. So this isn't a popular movie, Fate of the Furious, one of the movies in the Fast and Furious franchise. So with autonomous vehicles, they are more connected into basically satellite positioning, cell phone, Bluetooth. So there could be a potential for cybersecurity attacks. So right now, as we can see in the video, this is with passenger vehicles, but if we kind of take this same idea and put this onto 18 wheelers, kind of understanding the implementations or the implications that could affect truck driving, right? So as we can see here from the movie, it's simply just creating chaos and hazards with vehicles basically operating on their own. As we stated, 18 wheelers have more mass, the more ability to create more damage. So it's definitely something that kind of plays in the mind of the public as we move into autonomy. What's going to stop somebody from simply hacking into a vehicle uh, and controlling it? And this cybersecurity hack was also done in 2017. So the Jeep Cherokee was hacked essentially. Of course, the people had previous access to the vehicle, so it wasn't simply just hacked over the communication protocols, CAN or Bluetooth, and they were able to control the vehicle by driving it, steering it, and then ultimately basically shutting it off on the highway. So it is something that's currently being discussed. Standards have been produced, so there's a international standard ISO 21434 for cybersecurity, which has been produced to help mitigate the potential hazards, threats, if you will, as they're called in the standard, through a threat analysis risk assessment to help prevent some of these potential mishaps. And last but not least, the trolley problem, right? So the trolley problem is a thought exercise, basically that, excuse me, that has us pose the question in our minds. If a trolley's basically driving down the track, or we can think about a car or a 18 wheeler specifically driving down the street, and you have two paths, one path with a certain amount of civilians versus a path with fewer civilians, which path should the vehicle take? In this thought experiment, the injury will happen to somebody, but how do we determine which path is the path of least resistance or the path that somebody should take, right? This often becomes a problem because if we think about a human driver, either path taken, the human will be held accountable, it will be reviewed through the court of law, and they will be held to the highest standards. Usually, a jury of their peers would also review them to determine if that was the best possibility. We would look at the evidence and how this situation occurred, if they were under the influence. So we feel like justice would be served if a human was driving the vehicle. But when we look at advanced autonomous technology, there's no human in the vehicle. The trolley problem seems to come up often in conversation as to what should be done, how should this situation be avoided, and if the situation is encountered, what would be the best approach to move forward. So now if we look at some of the literature review, we'll get into publications from IEEE that have been released in the past 6 years regarding autonomy, kind of self-driving capabilities, and some of the ethical concerns or ethical thoughts around that application. So the first paper here is kind of Trust FSDV, so Framework for Developing and Maintaining Trust in Self-Driving Vehicles. The paper basically uh, analyzes the dynamics of trust for autonomous vehicles from perspectives of all stakeholders to determine the trustworthiness. So the paper breaks down the various stakeholders with a Venn diagram that shows everybody's quote unquote skin in the game from government institutions. This could be federal, state, city. The end users, so that could be, our logistics companies, our own operators, um, so on and so forth, and then the OEM. So companies like Peterbilt, Daimler would be for our situation, and how these stakeholders need or should collaborate in order to start and launch a campaign to build trust between overall majority of the public and society as we look to develop self-driving platforms vehicles. So the IEEE started a global project with the P7000 standard to address some of the ethical concerns during the development, so the system design and development of intelligent autonomous vehicles systems. So it's not waiting until the vehicle platform is fully developed, but it is trying to get ahead of the curve, start with the concept of design, making sure that ethical theories are being built in instead of added on at the end of the actual design phase, right? So this paper basically concludes with the idea that cross-functional collaboration is required, not just in the vertice of automotive and maybe more of the mechanical electrical engineers, but also into psychologists, sociologists, and more other cross-functional disciplines to help account for maybe edge cases or other scenarios, human factors, if you will, that most engineers might not be privy to, might not think about, in order to develop a more robust framework for developing uh, self-driving vehicles and also building that trust. Our next paper here is avoiding the intrinsic unfairness of the trolley problem. So if you remember, as I just discussed, the trolley problem presents thought that if we're faced with basically two scenarios of striking pedestrians, which one should we prefer to take, or which one should the platform take, the autonomous platform take? All right, so the paper outlines the argument that the trolley problem is a flawed thought experiment and not practical for guiding ethics for autonomous vehicles. So it breaks down why the trolley problem should be obsoleted or should be shelved because it's not really a viable argument in today's day and age. Right, so the intrinsic unfairness is due to determine the value of a person's life was one of the arguments, stating that in order for this thought experiment or even trolley problem to be effective, we have to basically rank or weight every person's life in order to determine which situation the autonomous platform would take. For example, if we have, a doctor on one path, and then we have maybe unemployed individuals, it could be four or five on the other path. The doctor, surgeon, psychiatrist, or whatever the discipline, the doctor may have the ability to save more lives. All right, so it may be deemed that the doctor's life is more important than the five unemployed. But once again, it's unfair trying to quantify, right, rank the value of somebody's life in such a way, right? It's kind of it violates a lot of people's thoughts on various human rights laws and morals and ethics, right? So even the German Ethics Commission, excuse me, declared that the trolley problem is unethical and that it should not be used for the development of guiding ethical theory for autonomous vehicle platforms. We should leverage maybe other type of specific use cases or view the loss of one life is equal. So all lives are essentially worth the same. So we're not trying to triage, right? So determining how many people could be left to not make it versus those who could be. We're going to try to save as many people as we can, essentially, right? So the paper concludes basically saying we should focus on practical technological solutions and their impact instead of kind of the theoretical pie in the sky concerns and problems that really aren't substantiated in society. The next paper reviewed was can you program ethics into self-driving cars? So this paper argues that in the future, software programs will be held accountable for vehicular fatalities caused by autonomous vehicle platforms and self-driving cars. So this kind of goes into the idea that, kind of as I discussed, if a human operator ends up getting into some type of vehicular homicide to where they're driving a car, strike a pedestrian, the pedestrian loses their life, that operator will be tried in court, going through the due process and the legal process. Whereas if we look at an autonomous vehicle platform, um, who will be held accountable in that? So it's going back. Okay, well, what did the software programmers and the engineers actually design in the platform? Why wasn't it able to identify the pedestrian? Kind of what went into the overall design and development, right? So OEMs and developers will have to defend a car's action in ways unimaginable compared to human drivers of today. Um, and this paper basically concludes with the idea that ethics of road automation is a solvable problem, basically stating that we have to try to solve it in small pieces, right? So a good adage is either A, we don't try to boil the ocean, or B, the question of how do you eat an elephant, kind of one bite at a time, or even a journey of 1,000 steps starts with one step. So it's not trying to think about all the potential and conceivable ways that the autonomous vehicle can create fatalities, but it's to work step by step, kind of frame things out, build your operational design domain is what it's called in engineering, and then identify potential hazards of the pedestrian or the potential fatalities that could occur, right? So it just needs to be a well thought out and defensible argument. And it kind of is stated there's multiple standards that are developed. Like I said, there's ISO 26262, which is a functional safety standard developed to design and develop safety into the vehicles. There's also a standard safety of the intended functionality, nicknamed SOTIF, which is ISO 21448, that is designed to develop a system that does not have a malfunction, but it operates in a way that is not design intent. So this could also play into that kind of vehicular fatality that's being discussed. The last paper here is self-driving cars, right? So ethical responsibilities of design engineers. This paper kind of caveats some of the last paper as well. So it reviews the moral responsibilities of engineers who are designing the autonomous vehicles. Uh, it breaks down the conversation that happened in the 70s for those who are old enough to remember or just aware of the situation of the Ford Pinto and the negligence of kind of the placement of the fuel tank, which when in rear end accidents basically turned into a fireball on wheels. Um, and the thought of that back then probably, we have to understand kind of maybe why this was overlooked or what steps went into the overall design. What was the process? Why did this allow itself to enter the market for civilians, or what responsibilities should engineers have in order to prevent that, right? So the paper basically breaks down is a case study, 1970s Ford Pinto, the negligence that happened, and how do we prepare society for autonomous vehicles and the concerns that many of them have today, right? So we kind of went through some of the ethical concerns from like the Frankenstein complex, the car coming alive and doing what it wants to, or even a car being hacked and doing what somebody else, a bad actor, is telling it to do. And then engineers should be granted more authority to make ethical decisions. So more in recent days, we have GM with a few different issues from the um, ignition issue of the Chevy Cobalt, which created potential problems. We have the 2009 issue of Toyota having unintended acceleration. So the vehicle basically is accelerating without user input or driver request. We have, once again, Takata airbag recall from failed airbag sensors not deploying when they should. So we have multiple uh, engineering issues with our current design of automotives. So the public wants to make sure that we have better checks and balances, more onus and ethical responsibility is placed on engineers designing and developing these platforms, kind of holding them to a higher standard as to prevent some of these potential hazards that could cause fatalities and loss of life. All right. So in conclusion, in order to not repeat mistakes of the past, OEMs should be more transparent, kind of on how autonomous vehicles are designed, developed, and tested. There should be peer reviews. We should be following uh, kind of best practices or state-of-the-art development standards. Some of the ones I kind of mentioned before, the ISO 26262, ISO 21448, in order to design these next generation autonomous platforms uh, in the best thought out way possible, having that defensible argument and ensuring public safety, should be our number one priority over anything else. And that kind of also breaks down kind of literary summary, right? So we have the first objective, right, to build that framework of trustworthiness, right? So identify those stakeholders, those cross-functional collaborators, get together and build out exactly how we will identify, define, and implement trustworthiness and ensure we have the uh, trust of the public, avoiding the idea of the trolley problem being a driver of ethical theory, looking for more technological problem-based solution approaches and scenarios that kind of affect our current day and age. Um, Kind of the ethics of road automation, is a solvable problem. Once again, starting in small bites, building out into larger sections, not trying to overreach or once again boil the ocean. And then ensure we have that transparency, right? So a lot of the transparency kind of comes out in discovery and the court of law, but it should be before that. We should be able to show that OEMs are following these very rigorous or robust development cycles that is best practice or state of the art, that there's peer review between different OEMs, and that everybody is kind of doing their best or with the best information we have today to develop this to ensure public safety when it comes to autonomous vehicle development. With that, we'll go through some of the ethical theories that were studied in the course. First one being virtue ethics, deontology, and utilitarianism. So first one here is virtue ethics. So it's Aristotle's or Aristotelian ethics. Aristotle is one of the founders of it. It comes from the Greek uh, ethical theories. It's more agent based, so it's based on the character, the person, the individual, and how their behavior attributes to them kind of reaching a morality. Leverages a lot of kind of use case in previous situations. So learning from more, I guess, of learning instead of following maybe like a strict set of rules or conditions. But it's kind of more so of growing into be an ethical person, right? We also discussed kind of the golden mean, right? So it's the sweet spot in between a virtue, um, such as justice versus being on the extreme side of virtue or the deficient side of virtue. And like I said, so the such a question is often thought kind of what kind of person should I be? So if we look at how we would apply this to the realm of autonomy for semi trucks, so it's looking at the designers, the software programmers, identifying their responsibility, their overall behavior when it comes to developing these platforms. So it's trying to instill virtues and morals or morality in their disposition as they're building autonomy into vehicles, semi trucks, 18 wheelers, if you will, and helping to frame that. But it's also helping the platform, right, the autonomous platform, determine ethical uh, approach based off of the theory of ethics, right? So when an autonomous platform is approaching a situation, they will basically leverage either past scenarios and situations and make a determination off of that information, right? So it's not going to be uh, based off if then statements and rules. It's more based off of use cases or a case by case scenario. So some things in certain situations might be acceptable, whereas in other situations they may not apply. So deontology, known by Immanuel Kant, also called Kantian ethics, focus more on a rules-based approach, right? Similar to the Ten Commandments, following a strict set of rules. Everyone follows these rules. They're universalized. So we see a categorical imperative, right? One acting in a way that everyone else should have to act. Um, and kind of even determining what that rule should be, which is a maxim, which is a definitive statement, usually with the word shall. And then from there, is everybody able to follow that same rule? And if so, what would society look like? So for engineers, so this would be following maybe laws and regulations, if you will. So they'll have to do X, Y, Z. If not, there will be consequences. So this could be enforcing more of the development design of the rules on how they have to check the box, checks and balances, peer reviews, code reviews, what have you. And then as far as the autonomous platform, it is, I guess, programming the vehicle to follow a certain set of guidelines, regardless of the case, regardless of the scenario. The vehicle shall do this when this is presented in front of them. The vehicle shall do this and shall do that. So this could have some potential upside. This could be a potential way to advance the development um, of autonomous platforms, but we'll get into more of that later. And utilitarian or utilitarianism, father of utilitarianism is known as Jeremy Bentham. John Mill is also one of the contributors to utilitarianism, presenting a lot of different works, really kind of championing the progression of modern utilitarianism, right? So it's more of a rationale-based approach. It discusses the uh, ethics or morality is defined by the maximum good for the greatest number impact. So it's the consequences of an action instead of the character of the person performing the action or the rules that the person followed in order to complete the action or the duty, right? So it's more so of what happened, the consequence of the action, and how did that impact the greatest number of people. So this has potential concerns, right? So this kind of goes back to the intrinsic issues of the trolley problem. So if, once again, if you have a higher contributor of society versus those who may not quote unquote contribute as high based off um, maybe somebody's viewpoint, uh, then we have to create some type of system or database that the vehicle could be able to see and determine, or we get into more of robots operating in a sense of triage. So now it's determining that the people who are able to be saved will be saved versus those who aren't. So, you can have this autonomous semi truck maybe veer to a path to where people are already injured in order to save people who maybe aren't injured, which could create more headache and issues, and also other ethical concerns to overall society if vehicles are making determination on human life. So maybe not leveraging this theory 100%. Maybe there are some aspects of it that it could be determined, but this may not be a good approach. So just to recap, right? So ethical theories, on the left-hand side of our tree, we have the ethical theories that are involved with conduct. Deontology, right, focuses on duties, the kind of the rule-based approach. Utilitarianism focuses on the consequences of the actions, maximum good for the greatest number. And on the right hand side here is more character based. So based on the individual, who should I be question is posed. Virtue ethics focused on the character. Now, if we take a look at the application, right? So applying the proposed ethical theories together, um, leveraging a hybrid approach is probably more advantageous. As we mentioned, there are ups and downs and different concerns with the singular approach. If we think back to the earlier parts of the slide, this was also one of the issues with the sensor technology, right? So every sensor, camera, radar, and LiDAR has pros and cons, but if we leverage all of the advantages, we can help mitigate some of their downsides and weaknesses. So we'll leverage that same approach for ethical theories, right? Leveraging a hybrid model. So one way we would leverage the hybrid model is basically autonomous vehicle approaches a hazard. So the vehicle will determine, well, is this a previous situation or a new situation by reviewing the database of maybe learning situations or training situations or scenarios that have been installed. And then from there, if it is a previous situation and there's database information on it, it will apply, if applicable, the same results or the same actions, right? So applies appropriate actions for the situation because so many things are similar. However, it's a new situation. It kind of reviews a sets of rules, and maybe it will determine, okay, well, maybe we need a new rule because this is a new situation and a new scenario. And then from there, it will apply the action to help mitigate whatever hazard we're trying to mitigate. And then from there, this new situation will be uploaded into the overall situational database to leverage in the future. After every action, regardless if it's the uh, virtue ethics based approach, which is a similar situation, or if it's a new situation off of deontology, we can leverage utilitarianism to analyze and start to create some type of heat map or statistical model that helps us determine, well, what basically happened, the greatest good, or the overall impact to the people affected, and see if these situations need to be maybe adjusted a little bit, or if everything is kind of within its whatever tolerance determined, right? So if we're too far to one side, similar to virtue ethics, if we're too far and we have too much excessive, we need to come back a little bit. And if we have too much deficiency of good or impact caused or happiness achieved by the greater majority, we basically need to find the golden mean. So it's kind of leveraging the golden mean in utilitarianism uh, in order to make sure we're in that center point of happiness, right? So another solution, right, is to maintain employment. So ethical concern is technological unemployment. So in the images below, we have potential proposed theories. One is to, well, the overall theory is to leverage autonomy for some of the longer driving, right, called over-the-road trucking. Is maybe more of the longer hauls. This way, human drivers would be the initial point. So they would basically drive the first leg from the origin or the dispatch into maybe a location to where they load it on the autonomous truck. The autonomous truck then drives it over the road. And then when it gets to its destination, a driver unloads it and basically does last mile delivery. This way, we maintain human engagement. We reduce the amount of unemployed truck drivers. We still allow the opportunity for kind of the blue collar workforce to maintain salary, income, and can kind of build their life that way going forward. So, in conclusion, we are well, the industry is currently developing various applications. The industry is addressing concerns with autonomous trucking as we are looking to push the envelope and move into kind of the next generation of truck driving. And although we know that this will allow a great benefit, as once again, logistics and truck driving is a vein or heartbeat of America, we don't want to inadvertently displace workers. So, while autonomous semi trucks offer great benefit to society, There are ethical obstacles that need to be mitigated to prevent unreasonable risks to stakeholders involved. So this is going through creating, like I said, the frameworks, making sure we are holding the developers of autonomous trucks, such as design engineers, software programmers, and coders, to some sort of moral standard or moral framework. And ethical theory is also leveraged when incorporating the design development to ensure we're really earning public trust, making sure that public interest is the number one priority to help mitigate the fears of, the Frankenstein complex, or to mitigate the fears that are being pushed in media, such as cybersecurity attacks, right? So it's still in its infancy. We're still working as an industry to kind of push and drive maybe more of uh, some of the technological concerns, but not to subvert ethical concerns, trying to just create the latest technology. So a lot more to do, but it's definitely a lot to think about, and make sure that the concerns are also being thought about and resolved as quickly as technology is being developed. And that concludes my presentation on the ethical theories and ethical concerns around autonomous semi-trucks. Here are some of my citations from um, the presentation. So thank you for listening, and enjoy your day.